A very good evening to one and all. Welcome on the 6th day of 1 week International Faculty Development Program on Research Methodology, Tools and Techniques. I hope you all are enjoying all the sessions. And today, the session is, I think, very, very important for all of us. And as you all know, today we have with us a renowned academician, great personality, a renowned researcher, Professor Dr. Manvinder Singh Pahwa sir with us. First of all, I welcome Professor Pahwa on behalf of Nirvan University and Inspira Research Association. Before I invite Professor Pahwa, I would like to mention some key points regarding Professor Pahwa sir. Dr. Manvinder Singh Pahwa, an alumnus of IIM Ahmedabad, is an eminent academician with a rich experience of 25 years, which is a rare blend of academia, industry, corporate consultancy, and research. His area of expertise is entrepreneurship, business finance, and corporate laws. Besides his graduation, post-graduation, and PhD in commerce, he is professionally qualified as a company secretary. He has also bagged gold medal in LLM, MBA, and top merit position in LLB, PGDHR, and PGDIB in the university. Dr. Pahwa has been actively involved in consulting and practicing as company secretary and corporate consultant and has incorporated and wound up more than 200 companies. He was also involved in fundraising from both internal and external sources, including project financing from banks, financial institutions, and NBFCs. Besides, he has good experience in managing IPOs. Dr. Pahwa has conducted and delivered more than 150 special courses and management development programs for corporates like IIFCL, IPL, Indian Oil, ONGC, PFCI, to name a few. He has been active in delivering faculty development programs for a number of government and private institutions, including AICTE, ICSSR, and UGC-sponsored FDPs, UGC HRDC refresher course orientation programs throughout the country on research methodology, pedagogy, personal effectiveness, and work ethics, soft skills, SPSS, legal compliances, entrepreneurship, and financial modeling. He has participated at numerous national and international conferences, chaired the session in India and abroad, and his 70 research papers are published in referred national and international journals, including Scopus, conference proceedings, and books. 8 PhD scholars have already been awarded PhD under his guidance, and more are pursuing. Last year, he was also awarded with 3 patents. And currently, Professor Pahwa is working as Professor, Department of Commerce, Dr. Hari Singh God, Central University, सागर मध्य प्रदेश. सर कुछ छोड़ा ही नहीं सर आपने बाकी. It is our pleasure, it is our honor to have you as a resource person for today's session, sir. Sir, I welcome you. Welcome, sir.
It's all the grace of God and blessings of all the elders.
Thank you, sir.
उनके आशीर्वाद से ही है सब कुछ. So, thank you. Thanks for inviting me and considering me for this particular international FTP, which I think for the first time is being organized at an international level by Inspira Research Association and
Yes,
Nirvan University. I think this is the first event that of a FTP. So, because Inspira has been doing a lot before also, and I'm fortunate to be a part of it. And even I would say, and I would vouch over here that I have also grown along with Inspira. So the opportunities which are being provided, it is means it actually forces you. It actually induces you to study more and deliver better. So it's like that. So I'm here in front of all of you, and the heartiest namaskar to everyone. And today's session particularly, definitely it's a multivariate analysis and factor analysis particularly. I hope Raviji, you have forwarded the file.
Yes, sir. I have forwarded.
Yeah. And I hope everyone is having SPSS with them. Though SPSS will be used afterwards, we will be clearing some doubts of the multivariate, what actually it is. Right from the scratch, we will be starting. So accordingly, we will be proceeding further. Yeah. So, can I start?
Yes, sir. Yeah, sure.
Okay. Thank you. With the blessings of SS Modi, sir. Sir, with your permission, please.
Yeah.
Thank you, sir. So, with you. Raviji, what is visible on the screen?
Yes, sir. Your slide is visible, sir. I mean, the banner is visible.
Okay. Okay. Fine. Yes. So, before we start, because this is a FDP particularly on research methodology, tools and techniques, and today is the sixth session which we are going to have. And let me please tell you that we all will be learning together. It's not like that I will be delivering and you will be learning or something like that. It's not like that. So we all will be learning together. So please make this as interactive as you can, right? So most of the time, whenever you want to open your mic and say something or raise your hand, and Raviji will be there to just make it, because in that way we try to, because I use chat box a little bit less than rather I would like you to just open your video and interact with me or interact with everyone else. So let's start it with this. So first of all, before we go further, uh, uh, this is something which is which we have it's not a yeah. So we can start with that. What actually is multivariate analysis? Anyone? What is multivariate analysis? Anyone? Can anyone define or just give an example of multivariate analysis? Yes, Raviji, you can please take up the things. Yes, no one.
Yes, they can unmute and they can type, sir.
Yes, yes, they have to do that like that.
Yes.
I use the chat box a little less. So please unmute yourself and please tell us that you raise your hand first, and Raviji will tell you that who will be able to answer. And accordingly, we will make a decorum so that online platforms works like that. Yes. Anyone? Yes, Prachi Tiwari ji.
Good evening, sir.
Yeah, very good evening, ma'am.
But with the name, I can try to tell you
Yeah, yeah.
multivariate may be where more than one variable or two variables involved.
Okay.
That analysis may be multivariate.
Any example?
Example maybe like it can have psychological capital.
Okay.
Its performance on, its effect on performance, organizational performance, and individual performance.
Okay, so there are various other things which are actually impacting one thing. I think you want to say that.
Yes.
So Prajwal Kumar, what you want to say? It would be good if you can come up with your videos.
Sir, this is Dr. Shiny.
Okay. Can you please open your video? Yeah.
Good evening, sir.
Yes.
Yeah. Basically, I feel multivariate analysis means where you analyze more than two variables, multiple variables, and find the association between the different variables.
Is it only about association or is it something beyond that?
Relationship.
Okay. Yes.
Uh,
Relationship for sure. Yes. Yes.
Yeah,
Relationship.
maybe to find, for example, employees' productivity and the time spent within the organization. If we want to find out different employees.
Excellent. This is the bivariate one. There are two variables on the impact of one you are seeing on another. In the same way, if there are one variable, the impact of various others which is being seen on one. That can also be one of the example of the multivariate. Anyways, so just let me just please have a look of this. That just consider this, that analysis of customer satisfaction. Suppose, for example, gender male and female is there, and type of banks means we just want to understand the customer satisfaction on banks in cities. So we just want to understand whether the gender is impacting, or it is a public and private sector bank, or a metro, or a non-metro. So what type of analysis it will be called as? Univariate, bivariate, multivariate, or all of these? Anyone? Yes, please. It's just a situation in which, so that we can learn better. We can just have a better analysis of the things, so that from where we start. Anyone of you? Yeah.
Maybe bivariate. As per
Okay.
me, bivariate.
Okay. What else?
Multivariate.
Okay.
Multivariate.
Multivariate.
Yes.
Yeah. Anyone else? Come on.
Multivariate, sir.
Okay.
Multivariate, sir.
So let me just give you a surprise.
Multivariate,
It's
sir.
it's a univariate. Now see, can you see gender, banks, and types of cities? What actually we want to understand and know. Why it is univariate. Actually, you have all used your good conscience that it is a you can say multivariate. Most of you have said that it is multivariate. Actually, 3 different types are given, so more than 2. That's why it is a multivariate one. Can you understand and know that all these variables are categorical variables? Huh? Male, female, gender, it's a category. Either the bank is a public or a private, again, it's a category. Again, if we are trying to understand whether we are doing it in metro cities or non-metro cities, it's a category. No variable is having any impact on any other variable. So, can you establish a relationship? Can we establish any relationship over here? No. We cannot establish any relationship particularly, because the variables are not of the type which actually makes us establish any relationship. Am I correct? Right?
Yes,
so,
sir.
Yeah. So this type of analysis cannot be called as a multivariate one. So let us now understand what actually multivariate analysis is. Right? So when we talk about what multivariate is, so you can say it is nothing but an extension of a univariate and bivariate. It is an extension. So if we expand it, it will be converted into multivariate statistics. Or in other words, you can say multivariate statistics is, you can say it's a general case of univariate and bivariate, or you can say special case of conversely, if we expand the univariate or bivariate, it becomes multivariate statistics. But in this case, taking a decision on the basis of number of variables is not suitable. Right? So it comprises of multiple variables but not necessarily like you can say ANOVA. You might have heard about ANOVA analysis. And it is correct that the multivariate methods involve analysis of many variables. But had it been on the basis of the number of variables, the three-way ANOVA or the four-way ANOVA is not considered as a multivariate, right? But MANOVA, if we say, is a multivariate technique, as it comprises of multiple dependent and independent variables. Okay, so why it is so? Because of the comprising of multivariate dependent variable and independent. ANOVA as such, you can say, may also be considered. Had it been having, but it is having only, it is only a univariate one. Thus, multivariate actually provides a facility to do a analysis of multiple levels, right, of a variable at a time, rather than doing analysis multiple times. Okay, so can statistical method be classified as a multivariate on the basis of the multiple dependent variable or an independent variable? So this is again a thing, right? So what actually is multivariate analysis? If we talk about what actually multivariate analysis is. So we are actually what we are doing. We are therefore merely because of the existence of two or more variables, now which we have just now discussed, that existence of two or more variables in any statistical method cannot make it a multivariate method. And also it cannot be classified on the basis of the existence of the independent variables or the dependent variables. But some features together can be helpful for us to be called as a multivariate statistics, right? So the number of variable is more than that in the univariate and the bivariate. Okay, so there can be multiple univariate or bivariate variables like in multivariate analysis. Further, some subset of these variables are there which we analyze altogether. That is, in some combined manner, right? But what kind of variables do we combine? Again, it's a matter of discussion and it's a matter of debate. So there is no unanimity among the authors regarding this. So some people are saying something, some are saying something else. But again, this is again a matter of discussion. Rather, now this is Stephen James in 2002, if we see. So if dependent variables are two or more, then it can be called as a multivariate. That's what he has actually said. So this actually concludes this excludes multivariate regression analysis from it, and also factor analysis from the category of multivariate analysis. As in multivariate regression analysis, there is one dependent variable, and we study the impact of multiple dependent variables on this dependent variable in a multiple regression. Further, in factor analysis also, that we are going to study today also, further in factor analysis, we do multiple correlation. So in that case, independent variables and dependent variables, we do not consider as such. So when we are considering variables, particularly in factor analysis, then there are not many variables which we are considering, and we are trying to establish a multiple correlations between them without considering that any variable is dependent on any other variable. So if we try to say this will exclude the factor analysis from the multivariate analysis if we consider the definition what is being given by Stephen James. Now, Tabachnik and Fiddle, they have again given they are also one of the, there is one famous book of multivariate analysis by Tabachnik and Fiddle. And what they have said is that with multivariate statistics, we do simultaneous analysis of multiple dependent and multiple independent variables. So if we see this definition, factor analysis cluster analysis, multi-dimensional scaling will be excluded, as we do not distinguish between the independent variable and the dependent variable in any such type of analysis. But both definitions are not considered as a suitable one. Therefore, for multivariate analysis, there has to be more than two variables of them, and two or more are combined together to get the result. That's why I was asking that, can we establish a relationship between the variables? So if two or more variables are combined together to conclude or to come up with certain result, in that case only we can say that it's a multivariate analysis. Now, the confusion still persists. So the difference between variable and variate is to be studied. Right? Now, what is variate and what is variable? Right? So you can say there are various things in which we can just have a distinction between. So from the measurement point of view, it can be direct or indirect. From formation point of view, it can be either weighted or composite type of things. So let us just understand what particularly when we say it's a the variate and the variable are there, then what actually it is. Anyone can you please tell me what is a difference between a variate and a variable? Anyone? Variate and variable. Have you heard these words before? Anyone? Because we are talking about multivariate analysis, not multivariable analysis. I have just given you one hint. So can anyone tell me about this? And we have also seen one multiple choice from which we started. Yes?
The
Multi-
variable means
Yes, sir.
just would be it will be actually individual things, sir. But variate it has some kind of relationship. Sir.
Sorry, sir.
For multivariate, variate means it has relationship along with the variable. Whereas in variable, it is separate one. There need not be any relationship.
Hello, sir.
Yeah.
Sir, actually, variable maybe, for example, we can say the genders, variable maybe
Very correct.
something like gender, sir,
Very correct.
or male or female, whatever it is.
Yeah.
That it's called as a variable. Variate is the value what we are going to, for example, the sex, sorry, means gender is a variable. They are specifying male and female. That is variate, sir. Inside the variable. That's what I understand, sir.
Yes. So what you can judge is, or what you can say is that certain magnitude or certain numerical value to the each you can say each member of the group, or you can say not exactly the group, to the each variable. Now, suppose you are saying gender. So what are the two things, male and female? So each male and female will be the variables. You want to say this? Am I correct? Yes, madam?
Yes, sir. Yes, sir. You're right, sir. Yeah, that's what my perception.
Okay.
Thank you, sir.
Okay. Yeah, most welcome. Yeah. So generally, if we talk about the multivariate analysis, it means the analysis of multiple variables in a single relationship or a set of relationships, if we say. So, for example, the researchers has collected data on 3 psychological variables, right? 4 academic variables, suppose standard size scores and has been taken, and the type of educational program the student is in, for suppose, for example, 600 high schools he has done, right? So if this is an example, and she is interested in how the set of psychological variables relate to the academic variables and gender. Now see, the psychological variables are there, and now when we are talking about the gender means male and female. Madam has just now told about the variate. So the variates of the psychological variable will be interacting with the variates of the gender, and the outcome whatsoever will be there will be called as a multivariate analysis. So in particular, the researcher is interested in how many dimensions are necessary to understand the association between the two sets of variables, right? So we were talking about multivariate techniques as an extension. So many multivariate techniques are extension of the univariate analysis, for example, and that is analysis of single variable distribution, and a bivariate analysis, that's a cross-class classification, you can say, correlation analysis of variance, and a simple regression used to analyze two types of variables. For example, if we say the simple regression with one predictor variable is extended with the multivariate case and includes several predictor variables. In that case, what will happen? The simple regression will become the multiple regression, and it will be called as a multivariate analysis. A single dependent variable found in the analysis for variance is extended to include multiple dependent variables in multivariate analysis, or is again multivariate analysis of variance. Multivariate analysis, or you can say it is a MANOVA type of thing. So multivariate regression is an extension of a simple regression, you can say. That's what we have just now talked about. Other multivariate techniques like vector analysis, discriminant analysis are uniquely designed to deal with the multivariate issues. So there are particular, you can say, purpose for which the discriminant analysis or vector analysis are being used, right? So there are what are the confusions and the conclusions if we talk about. Some researchers use multivariate simply to mean examining the relationship between or among more than two variables, whereas other use them only for the problem in which they are multiple variables are assumed to have a multivariate normal distribution, right? However, the characteristics of truly multivariate analysis, you can say, what can it be, or how will you be able to conclude it, that all variables must be random and must be interrelated in such a way that the different effects cannot meaningfully be interpreted separately. So if you will try to have a separate interpretation of the things which are involved in a multivariate analysis, you will not be able to conclude it in a better way, or it will not give you a proper conclusion. Then we can say the analysis is a truly multivariate analysis. Further, some authors state that the purpose of multivariate analysis is to explain or predict the degree of the relationship among the variates, that is the weighted combination of the variables. Thus, the multivariate characters lies in the multiple variates, right? So multiple combination of variables, you can say, and not only in the number of variable observations. So for our present purpose, the multivariate analysis will include both multivariable techniques and truly multivariate techniques also, as a because the knowledge of the multivariable techniques is the first step. We have to understand that in order to have a multivariate analysis, right? So we will just now be starting with certain concepts. Just now, Madam has told you about the variate. So the first stepping stone is the of multivariate analysis is the variate. So it is defined as a linear combination of variables with empirically defined weights. Ma'am has just now told us about that. What are the variates? These are the actually parts of a variable. For example, she has just given an example, but here we cannot put weights because she has taken an example of gender, right? So here we cannot put weights over there because this is purely a categorical type of variable. So when a type of variable is purely categorical, we cannot put weights. It has to be a little bit, you can say, more complex, or you can say it has to be a higher degree of variable. We will be coming on that also. So a higher degree of variable which actually tells you that there has to be some weights. Then we can say that it will be a variate, right? So all the variables that are specified by the researcher, where the weights are determined by the multivariate technique to be specific objective. A variate of n weighted variables, suppose from x1 to xn can be stated mathematically as what will be the variate value in that case. So you have to assign weights to each and every parameter, and then you can get the variate value. So variate value will be where W1 x1, W2 x2, W3 x3, and Wn xn, where xn is the observed variable and Wn is the weight which is determined by the multivariate technique. So that particular weight will be told to you by the multivariate technique that this is something which it has concluded with, and accordingly the value of the variate can be taken up further. So this actually results in a single value. So what we are getting? We are getting a single value as a variate. So this is a single value which actually represents a combination of entire set of variables. So, and this entire set of variable is such that it best achieves the objective of the specific multivariate analysis. For example, in multiple regression, if you say, the variate is determined in a manner that examines the correlation between the multiple independent variables and a single dependent variable. In another case of, you can say, the discriminant analysis, if we say, the variate is formed so as to create the scores for each observation that maximally, you can say, differentiates between the groups of the observation. That's what discriminant analysis does. In the same way, if we talk about the factor analysis, the variates are formed to best represent the underlying structure and the patterns of the variables as represented by their intercorrelations. So in each of these instances, if we observe, in each of these instances, or in each of these examples which I have just now quoted about the regression, the multiple regression, discriminant analysis, and the factor analysis. Now, in each type of this thing, the variant captures the multivariate character of analysis. For each technique, the variate is the focal point of the analysis in many respects. Therefore, not only its collective impact in the meeting, the technique's objective should be studied, but also each separate variable's contribution to the overall variate effect is also to be taken care of. So yes, Kaushali, you have some question?
Good evening, sir. I hope
Yeah.
I'm audible.
Yeah, you're audible.
So, for example, if a researcher intends to study on a title called Influence of Bank-Specific Factors and Macroeconomic Variables on the Financial Performance of a case study of selected Indian public sector banks and private sector banks. So, therefore,
Are you doing some PhD on that?
no, sir.
Okay, so what is the purpose of asking this?
The purpose of asking this question is in reference of the concept multiple variate analysis, which you've discussed just now, in order to seek a clarity in terms of independent and dependent variable. This is my purpose of asking the question.
Kaushali, one question. What is your objective, particularly in this case?
My objective of the study is to analyze the influence of bank interest rates to be more precise, repo rate, cash reserve ratio, and statutory liquidity ratio.
Fine.
And it's how does it influence macroeconomic factors such as inflation and gross domestic product. So these will be the independent variables for the study.
You have yourself answered me. You have yourself answered your question. Now see, there are various multiple different type of variables you have taken, and you want to see a combined effect. Am I correct?
Yes, sir.
Yeah. So it is a multivariate type of study. Now, why? Various types of things you are taking, right? And what I told you, that even if you try to find out the impact of these all on one, if you remove any one of the variable, the entire thing will be distorted. Yes or no?
Yes, sir.
So that's why you cannot have a separate conclusion of a separate thing, which is to be means a separate variable. If you take, it will give you a different conclusion, and it will completely distort your analysis. So when such type of thing happens, when all the variables combined all together, impact of these are being seen on one independent variable. Now, these all are independent, sorry, one dependent variable. These all are independent variable, and you are saying one or two dependent variable also. Yeah, right? So if
Yes,
you are,
sir.
if you are
Total,
combining, yeah. How many variables total? I think 4 here you have said, and 2 more you have said. 6 variables are there.
independent variables for the study are repo rate, cash
Mhm.
reserve ratio,
Mhm.
and inflation and GDP.
For sure,
Whereas
yeah.
dependent
Mhm.
Whereas dependent variables for the study are profitability ratio,
Mhm.
not all, but selected profitability, liquidity, and solvency ratio. Profitability, to be more precise, it's return on assets, return on capital adequacy ratio,
Okay.
return on equity, uh,
Mhm.
return on equity, return on investment. And so far as liquidity ratio is concerned, it is CASA ratio, quick ratio, and
It's a multivariate, it's a purely multivariate analysis which you are talking about, right?
okay.
Yeah, and means because there is a complex relationship. Okay, hold on over here. I'm coming on various types of tests. Okay, so there you just try to understand and connect your question with those tests also. That what test will be applicable. Okay, partially I will get back to you. Okay.
Okay,
And
sir. Okay.
there you will be having a more clarity of your question. Okay, Kaushali?
Okay, sir. My concern was that is it possible to
Mhm.
take the study towards a multiple variate analysis or not?
Yes, it can be. It can be.
Okay,
Okay.
sir. Okay.
Yeah.
Okay, sir. Thank you so much, sir.
Yeah, most welcome. Okay. So let's now talk about the measurement scales. So I think you might have already studied about measurement scales over here. And if you have any idea of the measurement scales, metric, non-metric, nominal, ordinal, interval, and ratio, we can save our time. Anyone? Can anyone tell me about this? Yeah. So actually what the thing is, what we are trying to understand, the keyword over here is a measurement. Huh? Measurement. Because researcher cannot identify the variation unless it can be measured. So if we try to understand the variation, then first we have to measure, then only we can see whether there is a variation or not. Okay. And measurement is important in accurately representing the concept of interest, and it is instrumental, you can say, in selection of the appropriate multivariate method for the analysis. Okay. So until unless you measure, you cannot actually proceed further. So that's what, and that's why this scales particularly which actually measure the variable are called measurement. Okay. And further, if we talk about the data, so data can further be classified into two types of things. Better we say, a data can be a qualitative data, it can be a quantitative, or you can say the qualitative data is nothing but non-metric type of data, and quantitative data is metric type. Okay, so the researcher must define the measurement type, whether non-metric or metric, for each type of variable. So your concept, particularly whether a particular variable is of what type, whether it's a metric or a non-metric, and even if it is metric, non-metric, whether it's a nominal, ordinal, interval, or ratio, it has to be very much, very, very clear. Okay, so when we are entering the values in the computer also, then also we try to use the numbers. Okay, and I will tell you how to just actually go for it, right? So when we are talking about non-metric type of, you want me to explain metric, non-metric, or should I proceed further? Yeah.
Yes, sir. Please explain the
Okay.
metric and non-metric.
Okay, fine. Then carefully listen it because this is something very, very important when we are talking about the multivariate type of analysis, that what test we have to apply. The most important question which a researcher is having in the mind when they are doing PhD is that, sir, this is my data, what test should I apply? They come with this type of question. And you all might be having such question in your mind and heart that मेरा ये data है, तो what type of test I can be able to apply. So that we will do, right? So let us just talk about the this type of measurement scale. So non-metric data actually describe the difference in type or the kind by indicating the presence or the absence of a characteristics of a property. Now, what type of characteristic of property? So these properties actually, these are discrete in that by having a particular feature, all other features are excluded. For example, if a person is a male, he cannot be a female. So once a person is male, he will be excluded from any other category. If a person is a female, she will be excluded from any other category. Means a person can only be one. So in the same way, a person can only have one characteristic and rest all, because it is against everyone else. Okay, it is against the entire world that I am a male, so I am just a male. That's it. I cannot be anything else. Okay. So an amount of a gender, I would say amount. An amount of a gender is not possible. I cannot say that how much male I am or how much female one person can. So in such a case, if such type of characteristic is present, then the particular variable will be called as a non-metric type of, right? So non-metric measurement can be a nominal or a ordinal. It can be on a nominal scale or on a ordinal scale. Means once a person is in, because when we talk about nominal, it is something which will give you information not beyond something else. Means once you are suppose, for example, a person is a male. So male is a male, that's it. But at the same time, if a person is a professor, associate professor, and assistant professor, this actually tells you that there is an order in it. So that is called something which we call as a ordinal type of scale, right? So there some amount is, you can say it is coming. So nominal scale actually assigns number as a way to label or identify the subjects or the objects. So when we are punching the data in SPSS, rather when we just nominate that one is male or two is female, or one is female or two is male, whatever. So it is just not more than that. So numbers to the which are assigned to the objects have no quantitative meaning beyond indicating the presence or absence of that attribute or the characteristic under the investigation. It will not depict more than that. In that case, it is, you can say, in nominal scale it happens. For example, in representing the gender, male or female, just now I have told you that if we have assigned one number 1 to male and 2 to female, it doesn't make anyone great. Okay, it's just a category which will keep you in. Like, for example, a student is studying in a section A, section B, section C, where he is studying. So it hardly matters that studying in section A will make him superior or inferior, nothing like that. So it will just give you a category and not more than that, right? So nominal data only represent the categories or class and do not actually imply the amount of an attribute or the characteristics. So nominal scales can only provide the number of occurrences, or you can say frequencies, now in each class or category of the variable which is under the study. Okay. So with these values, however, we can only tabulate the number of males and females. That is, we can only consider you can say a frequency, not more than that. And it will be nonsense, or it will be senseless or baseless to just have the values associated with it. Or you can say, if it okay, let me just make you understand in that way. can we take the average of males and females? If 1 is equal to male, 2 is equal to female, can we have the average 1.5? It will be baseless, it will be senseless. So, such a case where the information is not more than that a thing is in that particular category is a nominal diagram scale. Now, in case of ordinal scale, I have just now told you that that this is a level which is higher than it is. The measurement precision is a little higher than that of the nominal. In the case of ordinal scales, variable can be ordered or ranked in relation to the amount of the attribute persisted. So every subject or object can be compared with another term, such as a greater than or less than. Just now I have told you about a category. Suppose professor, associate professor, and assistant professor. So there are 3 categories. So obviously it is not only categories, it is telling that a person who is in a category of a professor is, of course, superior than that of the associate. Associate is superior than that of the assistant. So it is a categorical type of thing. Again, at the same time, it is also telling us some order. Okay, so that's why it is called, it can be as a ordinal one. Okay, so the number utilized in the ordinal scales, however, are really again, the numbers are non-quantitative because they indicate only relative position in an order series, right? So ordinal scales provide no measure of the actual amount of the magnitude in the absolute terms, but only the order of the values. This is only giving you the order, nothing more than that. So the researcher knows the order, but not the amount of difference between the values. Actually, it doesn't, because it doesn't actually depicts the difference. Okay. For example, income level, anxiety level, rank of employment. These all are the examples. Just now I've given you the example of the rank of employment of professor associate. So you can just say general manager, or you can say deputy manager, assistant manager. So these are the rank of employment, which will actually tell you the level. But you cannot say that the magnitude, it is having some magnitude. Okay. So when we have a category, plus it is telling us some order, then we will call it as an ordinal scale. Okay. So if we say, when we measure this variable with an ordinal scale with a rank order, suppose the product based on satisfaction level, suppose we are talking about some satisfaction level. So we want a measure that reflects that the respondent is more satisfied with product A than product B, and more satisfied with product B than product C, based solely on the position of the scale. We would assign this in the order of rank. Suppose, for example, this one. Okay. So what does it tells you? That product A, I am highly satisfied. Product B, I am satisfied. And product C means product A, you are having, your satisfaction level is more than product B and product C. Right? So, and if we could assign the values of the satisfaction, for example, 1 to highly satisfied to product A, or 2 to the product B and product C accordingly, right? So that can also be done in order to put this in category and in a sequence. And further, a researcher may find it more attractive. This is just you can say the 3 products which just now I have shown how to make it further, right? So a researcher may find it attractive to use an ordinal measure, but the implications sometimes do not allow us to do so, because you cannot actually measure the things of satisfaction, for example. So the analyst cannot perform any arithmetic operation. You cannot take any sums, any averages, any multiplication, division. You cannot do, because these just only tells you the category. But the non-metric, thus the non-metric data are quite limited. They are having very limited scope in their use, estimating the model coefficients. Hence, the non-metric data should be properly identified and be used appropriately in the multivariate analysis. Now, it doesn't mean that the non-metric data cannot be used in the multivariate analysis. It's not like that, but you have to properly define. Okay, so many multivariate techniques are devised solely to deal with the non-metric data. Okay, for example, correspondent analysis is one. And to use a non-metric data and as an independent variable, you can do it. For example, discriminant analysis, I have just talked about the discriminant analysis. Where a non-metric dependent variable or a multivariate analysis of a variance with a non-metric independent variables can also be done. Right? Now let's talk about metric data, or you can say the interval data. Okay, so unlike non-metric data, metric data are used when there is a difference in the amount of magnitude. Now here, the information is rather much more than what we have seen in the non-metric one. Means the least from the point of view of information is the nominal, then the ordinal, which actually tells us that there is some order. Now here, a little bit more information we will be getting, or you can say this will actually tell you more magnitude is there. Right? For example, the level of satisfaction we have just now talked about. Level of satisfaction or commitment to a job. Metrically measured variables can be compared and contrasted relatively, but not the non-metric. So the arithmetic operation done with these variables makes a lot of sense, you can say, right? So as shown in the figure below, you can just see the measurement scales are in the interval in the ratio. Now this is the figure, right? Now this we used before also. Now here I am assigning the numbers to them, right? So both interval scales and the ratio scales provide the highest level of the measurement accurately, because they allow the performance of any mathematical operations in a sensible way. So these scales have constant unit of measurement. So the difference between any two adjacent points or any part of the scale are, you can say, equal. Okay, so this is an assumption. For example, we are just considering the same scale, right? Taken to understand the ordinal scale we have just now seen. We have the same scale I'm just taking. So metric data could be obtained by making the scale numeric from 5 to 1, which I have just now done, right? Where 5 is the highest level of satisfaction and 1 being the lowest level of satisfaction. So according to the average of the scores provided by the customers, product A, if we say product A was somewhere here, okay, 4.5. So product A is 4.5, product B is at 4, and product C is at 1.5, right? Somewhere here, product C somewhere here, 4.5, right? 1.5 in this scale. So now besides ranking the product, now ranking is already we have done. On the basis of satisfaction, as done in the case before, we can now make an inference that the difference between the satisfaction level of product B and product B is product B and what is the difference in satisfaction level of product B and product C? Anyone? How much it is? So product B is giving me satisfaction 4, whereas product C is giving me satisfaction 1.5. What is the difference in the satisfaction? Yes, obviously 2.5. It is more than the difference in the satisfaction score of product A and product B. Now, what is the difference between the satisfaction level of product A and product B? 4.5 minus 4.5, whereas product B and product C, it is 2.5. But as the satisfaction is not a relative measure, it would be inappropriate to infer the satisfaction of product A is 3 times the satisfaction of product B. Can I say like that? See, product A's satisfaction is 4.5. Product C's satisfaction is 1.5. Can I say like that? That product A is giving me 3 times more satisfaction than product C. Can I say like that?
No, sir.
I cannot. Why? Because satisfaction is cannot be measured. It is having no scale at all. But we have tried to make it like that. So that's why this comes under the interval. Okay. Now the greatest form of the measurement, or you can say the accuracy or precision, is depicted by the ratio scale. This is because they attain all the advantage of the lower scales. They also have absolute zero. What is the problem over here? In the last, which we have just now said, it is having no absolute zero. Now, what is absolute zero? Anyone? What is absolute zero? This is what is a difference between the interval scale and the ratio scale. What is absolute zero?
When 0 has some value, when 0 is defining something like temperature. The example
yeah,
of
yeah, yeah, you're very correct. You are very correct. You are on the track. What's your good name?
I'm Dr. Devyani Chatterjee.
Yeah, Dr. Devyani, you are well on the track. Yes, please tell. Temperature is an excellent example. Don't you feel it can be explained in this way? Don't you feel any hot or any cold at 0?
Yeah, we feel cold. We feel
Cold.
at 0 degrees centigrade.
So
That's why. Yeah.
some gratitude or some magnitude of temperature is there at 0 also, no?
Yes, yes, yes. Means
Right?
yeah.
So 0 is not 0 at that point. So I would
Right.
say it is not a true 0.
Yeah.
Can I say like that?
No.
Can I say like that? That it's not a true 0? Yes?
Yeah, yeah, it's not a true 0. It's not a true 0.
Absolutely.
Yeah.
Let's take example of time. Can you have a time when the time is 0? Don't say at night at 12 o'clock it's 0. Time is still going on. You have something before and something after. Every time, every moment.
Yes.
Right? It's again an example of interval. That's why it is called interval. Time is the best example of interval because there is some gap in between. That's why the scale is also called interval as such.
Yes.
But in case of ratio scale, we have the absolute scale. Yes? We can say that a person is having, suppose a person is having a weight of 30 kgs. Another person is having a weight of 60 kgs. Can I say that a person who is having a weight of 60 kgs is having double the weight of 30 kgs? I can say like that. Yes or no? Because this is having some specific level and level of measurement. And that's why these scales are called ratio scales, which actually gives us the highest form. And they also have absolute 0. And the examples are all those things which can be measured. May it be in terms of, because everyone, that's why we call it a scale. What we call, we have a scale. We have a scale, a 6 inches scale, a 12 inches scale. We have at our home. What it does? It measures the length. In the same way, we have the weighing scale, which measures the weight. Right? In the same way, we have, you can say, the scale to measure the liters, milliliters. So these all are well-defined, you can say, scales. So when the things are under well-defined scales, or it can be measured in the form of, you can say, numbers. For example, I have 4 cars. How many cars I have? 4. A person is having 2 cars. So I have cars double than him. I can say like that. Because it's a number. Number itself is a scale. So that will be called as a ratio scale. And it allows all type of mathematical operations, and that's why it gives us the maximum, you can say, information. Right? I have just given you the example of doubling the weight, right? So such type of things are there. So what is the difference between interval scale and a ratio scale? Again, what I called was the arbitrary 0 or the true 0. Right? So which is having a true 0? Ratio or interval? Ratio scales are having true zeros, right? Whereas the interval scales have an arbitrary 0, or you can say just a fake 0. You can, yeah. Okay. So this is what it is, and this actually makes a difference. Again, if you take the example of Fahrenheit and the Celsius temperature scales, now 0 degrees Celsius will be having some magnitude of Fahrenheit in minus. Okay, so it means that there is at least some things are there. So these are again the interval scales itself, right? Time is also an example of interval scale I have just now told you, right? So why we are understanding this? Understanding the different types of major scales is very important because of 2 reasons. First, the researcher must identify the measurement scale of each variable used so that the non-metric data are not incorrectly used as a metric data and vice versa. This is very, very, very important. Otherwise, what will happen? Otherwise, we will end up making a average of gender, which is completely incorrect and useless. It will be inappropriate if these things are used interchangeably. And second thing is the measurement scale is also critical in determining which multivariate techniques are most applicable to the data, with consideration made for both dependent and the independent elements, right? So in the discussion of techniques and the classification which we are going to do just now in this particular presentation itself. So the metric and the non-metric properties of dependent and the independent variable are are the determining factors for selecting the appropriate techniques which you will be using. So that's why this is another very, very important factor. Okay, so another thing is measurement error, and you can say multivariate measurement. So measurement error can be defined as the extent to which the observed values can not exactly represent the true values. I will just skip it because you might have studied this before also. So, just because sometimes you have observed some other value and the true value is something different, and the error is there because we keep on observing. If we suppose, let me just give you an example of suppose, for example, out of these 72 to 80 people, how many people are present now? If I try to take a satisfaction level of my class, because you are a universe of 80 people, suppose I pick up a sample of 8 people and try to take some value from it. And again, I put the sample back and again, I take some other people. So there will be difference in the values which I will be getting from the same population. So that particular difference is nothing but the error, you can say the error in the measurement that we have to consider, right? So this is how we can resolve this. You can go with the validity of the thing and you can check the reliability. Okay, that can be one of the things. What is validity? Validity is a degree to which a measure accurately represent what it is supposed to represent. Okay, so that can be one of the things. Okay, and you can just have it as an example. But what is reliability? The degree with which the observed variable measures is true value and is error free. That is what the reliability is. So I will not take much about the validity and reliability over here, though these are very, very important when we are studying the multivariate measurements. Okay, but for today, because we are just trying to understand, we are not going in depth into the technique, except one technique only I will be taking today, that is the vector analysis, except that the remaining will because it is a lack of time again, because it again takes me about an entire week to just have a, you can say, the FDP on a multivariate measurement or multivariate techniques. Sometimes else we can just have that. So there are you can say there are certain multivariate measurements which have to be taken, and these are also known as summated scales. For which now, what are summated scales? Suppose, for example, I am just asking someone that how much satisfied you are. He will say, okay, I am very much satisfied. But if I ask him, okay, you just give me the parameters. The various parameters are given, and I try to take the sum of those parameters as a satisfaction level. That what is called a summated scale, right? So what we can call summated scale or composite scale is where several variables are joined in a composite measure to represent a concept, or you can say the combination of all these will give me a concept. Okay, for example, if we are measuring a satisfaction, one could ask a single question just now I told you. Okay, and in that way, suppose, for example, I'm asking you that how much you are satisfied with your suppose banking services. Okay, how much time you go to ATM and you have found that there is cash in it? Was there a person who has been welcoming you over there? Was the ATM cleaned, or it was just all the chits and all these things were spread over there? Was the AC working over there? So if I take composite, you can say, score of all these things on a 5-point Likert scale and try to have a weighted average of it, I think that will give me much more accurate type of measure rather than just asking someone that how much are you satisfied. Okay, So that is how we go for a multivariate measurement also. And this again is depicting all those things which I have just noted. So how do measurement error and reliability affects? So reliability as a measurement, as the measurement error and the reliability are rooted in the detected variables itself. How they affect, it cannot be observed. It cannot be observed directly. Therefore, the researcher should always take a proper care to ensure proper reliability and validity. This will increase, you can say, perfect representation of the variables which are of the interest. Okay. If we talk about measurement error, if the measurement error is high, you can have poor results. But the presence of measurement error is guaranteed to distort the observed relationship and make a multivariate technique less powerful. Okay, so what we should do, we should also again try to reduce the measurement error, although it takes a lot of effort, time, and you can say additional resources, which may improve weak or marginal results and strengthen the proven results as well. So we can do that, but more efforts are required. For example, you can just increase the sample size. So that's again will make you more. You have to take some more efforts in order to do that. Okay. So, but if less measurement error are there, then it is rather better. Okay. I hope you understand about the statistical significances, the error and the inferences. When we talk about when we take a sample from the population. Okay, I think this is well been covered in the other previous classes also. So I'm not taking much more. Type 1, type 2 error also might have been taken up because hypothesis testing you have already studied. Okay, so this is another thing which I have intentionally put up over here. Now, these days there is a fashion of applying multivariate techniques. Now, applying multivariate techniques these days have become a fashion. What you are I have applied structural equation modeling in my cases. Oh wow, means actually the innocent researchers, they apply this technique for the sake of applying it without thinking which multivariate technique will be applied, and then they get victimized because of the wrong interpretation and unrequired type of things. Once I was just evaluating one cases in which a factor analysis was unnecessarily applied. I just asked in the pre-thesis presentation itself that what are the objectives which are actually telling you or which is depicting you to apply such type of thing. The researcher was having no question except that she blamed the guide. That my guide told me to just apply this, that's why I have applied. But it is actually not solving any purpose in the particular research work. So that is sometimes it should be rather avoided, right? So which techniques to be applied when? That is again important. The selection of multivariate technique is based on the three things over there, right? First is the problem statement. Second is the research objective. And third is, which is very, very important, is the nature of data which is there. Now, decision is based on, now see, classification of variable. Okay. Can the variable be divided into independent and dependent based on some theory? It is to be seen. So it constrains to think whether the technique to be used is dependence techniques or interdependence techniques. Okay. Second thing is the number of variable in each classification, right? So how many variables are treated as a dependent variable and how many variable are treated as an independent one in one analysis itself. And third thing is measurement of the variable itself, that how the variables are being measured, both dependent and independent, means how these are measured. So these are very, very important things which we must understand in order to know that what type of technique or multivariate technique we need to use. Okay, so I have told you a lot of things about the multivariate technique. So let us just now come to a conclusion, or let us just now discuss about that. What are the various things which we have to do? It's 8:15 now. Let me just run through it. So it's going to be 15 minutes more. So predictor, now here, I'm just telling you about, there are various multivariate data analysis techniques. Now, again, first we have to start with the type of relationship. Whether it is a dependence or interdependence technique, I have just now told you about what these are. Secondly, if it is the type of relationship is a dependence relationship. Now, variables to be predicted are multiple complex, they have multiple complex relation. Then you have to go with the structural equation modeling. Multiple complex relation means they are interrelated with each other also, and dependent and independent variables are also related. And there is a relationship of dependent and independent also. There is a relationship between the dependent variable also, that to some extent they are also interrelated. In such a situation, you should use structural equation modeling. Now, next is the variable to be predicted are multiple dependent variable. And in that case, in case of multiple dependent variable, the measurement scale of, or the measurement scale of the dependent variable is metric. Then measurement scale of the predictor variable. Predictor variable is the variable which is used to predict some other variable. In general case, it is an independent. You can say the dependent variable is metric and the independent variable is also metric. In that case, you must use canonical correlation analysis. Okay. Further, if the dependent variable is metric and independent variable is non-metric, then you can use multiple analysis of variance. Okay. Further, if the dependent variable is non-metric in nature, then you can use canonical correlation with dummy variables, right? In the same way, if there are one dependent variable, now this was the case of multiple dependent variables. In case of one dependent variable, if you are having, then measurement and the measurement scale of the dependent variable is metric. In that case, you must use multiple regression, or you can go with the conjoint analysis also, depending on the situation. Further, if the it's a one dependent variable is there, means dependent variable is one, and there is multiple dependent variable, but dependent variable are non-metric. In that case, you can use discriminant analysis, or you can say linear probability models can also be used. Now, independence or interdependence techniques. If we talk about interdependence, the structure of the relationship among the variables is to be studied. Then we directly go for factor analysis. Why? Because factor analysis doesn't discriminate between the you can say the dependent and the independent ones. Next is, if there is a structure of relationship between the cases, in that case, we have to go with the cluster analysis, because the combination of various cases make a cluster. Okay. And if it is regarding the objects and the measurement scales of the attribute is a metric one, in that case, we use multi-dimensional scaling. And in case, if the structure of relationship is between among the objects and the measurement scale of attribute is non-metric, in that case, we will be using correspondence analysis. Okay, so you can take a screenshot of this. Is a very, very important information for all of you. I will just give you a time to take a screenshot. You can take a photograph of this, where which type of techniques are to be used. Okay. Now, dependence and interdependence again. So a dependence technique may be defined as one in which a variable or a set of variables is defined as a dependent variable to be predicted or explained by other variable, which is known as independent variable. For example, multiple regression analysis, it is there. We just talked about just now. I forgot the name of the girl I told to hold on. Khyati, sorry. What was the name?
So Khushali.
Khushali. I'm sorry. Actually, yeah. Can you just make it out now that what type of techniques can be used in the analysis which you are going to do?
Yes, sir. Now I could get the clarity.
Very good. Excellent. So that's why I told you to just, I will be calling you back. Okay. Thank you so much. So in contrast of the dependence techniques, The interdependence technique is one in which no single variable or group of variables is defined as being independent or dependent. Rather, the procedure involves the simultaneous analysis of all the variables. Just now I told you the example of the factor analysis, right? So it's factor analysis, right? So let us focus on dependence techniques first, and we can use the classification into the selected appropriate multivariate method. Now here the model building is there, so we can just understand that what multivariate determinants techniques in case of dependence can be done. When the variables to be predicted can be one dependent variable, multiple dependent variable, or you can say multiple complex relationship. That's what I have told you about that. Okay, so it tells you about what type of things it will be. So it is just now again you can say the another counterpart of it. Okay, so this is again particularly which is on the basis of the dependence. The previous one was on the interdependence. So this is for the dependence. You can just take a screenshot of this also. Okay, as a for dependence particularly. So when we are going in depth about it, then we can understand the relationship between the multivariate dependence method. So these are the equations which you can also have a screenshot of. Okay, so what type of model is being used particularly? Can take this shot also. Like what type of model will be used in the various type of, you can say the multivariate dependence methods. Okay, this is again interdependence methods, right? That we have already discussed about. Now there are various multivariate techniques which can be, means what type of things are there in each type of techniques is there. So 10 different types of models and techniques are being discussed, right? And out of this we will be taking the factor analysis, or you can say principal component analysis as such, right? So what factor analysis is about, where I will be just taking you to my further slide, just a moment.
Sir, if I can place a request.
Yeah, sure. Please. Tell me.
At the end of the session, I have a query in reference to factor analysis concept. Is it okay if I ask at the end of the session?
Why not? Because let me just, I think you will not be having any query afterwards. Let me just tell you about
Okay.
factor analysis first, right? What actually it is, and we will start from there itself, right? I think
Okay,
you will not be, yeah. Let's see. And still, if it is there, I'm there to help you out. Even you can have my number also. Okay, anytime you can just give me a call and we can just, go with it. Okay.
Okay, sir.
Yeah. So half of the screen is coming here. Just I hope full screen is being displayed.
No, sir, we cannot see anything.
Okay, just a yes. Now can you see the full screen?
Yes, sir. Not as
Okay.
visible.
Fine. So let's talk about factor analysis, which is the part of it, right? So what factor analysis is? So as I have told you, that it is a interrelationship among the large number of variables, right? And we do not classify these variables as a dependent and the independent variables, right? And we are trying to actually explain the underlying, some common underlying dimensions which is inside it, which we call it as a factor, right? So particularly if we talk about the objective of it, the objective is to condense the information contained in the number of original variables into a smaller set of factors with a minimal loss of the information. So this is also helpful in creating the summated scales. That what is the main thing for which this is used. Okay, so factor analysis, for example, can be used to better understand the relationship between the customer rating of a fast food restaurant, for example. Okay, so just imagine that you ask customers to rate the restaurant on the following variables. You are owner of the restaurant, okay, and you have asked your customers to give some rating to you on the basis of food taste, food temperature. Food temperature means the thing which is served to you is if it is a cold drink, it should not become hot, and if it is a pizza, it should not become cold. Okay, so the food temperature. Freshness can be one of the variables. Waiting time, how much time you have to wait, because more waiting time actually results in less satisfaction. Cleanliness or hygiene, you can say, and the friendliness of the employees of that particular restaurant where you intend to go, right? So the analyst would like to combine these six, you can say, variables. So now we have six variables with us. What are these? Food taste, food temperature, freshness of the food, cleanliness, friendliness of the employee, and the waiting time. So these are the six things which we have. So on the basis of these six, we just want to have, means I just want to suggest to, or I just want to have a suggestion to my management or to myself that what should I do, means in order to just have this. So what I will do is, I will go with the factor analysis. Okay, so this technique will tell me that how I will. So what actually is happening in factor analysis is that, suppose for example, if we talk about something which is having an interactive type of, now see this, the image on the screen itself. Someone who is a playful one, full of joy, he performs well, he's having a good efficacy or usefulness. So what type of impression will you get out of it? So this is what we do in factor analysis. We try to see the underlying factor in the variables itself, right? So that is technique which we call factor analysis. So it's a general name denoting the class of the procedure primarily used for data reduction and summations. So factor analysis is an interdependence technique. Why? Because it will try to come up with a interdependent relationship which is examined without making the distinction between the dependent and the independent variable, right? So dependent independence is something different, which may consider in regression type of analysis. No, what is the use of factor analysis? This is used to identify the underlying dimensions of the factors that explain the correlation among a set of variables. And it tries to identify new or smaller, or you can say set of uncorrelated variables to replace the original set of the correlated variables in subsequent, you can say multivariate analysis called regression or the distribution. Means first you can go for factor analysis, try to understand whether there is an interrelationship or not. If you find it out, then you can further go for a multiple regression or a discriminant analysis also. Right? Further is to identify the smaller set of salient variables from a larger set to use it for a subsequent multivariate analysis. Because multivariate analysis, we keep on doing lot many of variables, it will be meaningless. Rather, if you can reduce the variables at an initial stage, the multivariate analysis will give you a benefit. Okay. So each variable is expressed as a linear combination of underlying factors. The covariation among the variables is described in terms of the smaller number of the common factors plus a unique factor in each type of variable. If the variables are standardized, the factor analysis model may be represented as this particular equation as such, because it is having a multivariate type of thing. Okay. Now this is all about the donation connotation about this particular can say equation. Further, if we, so I'm not going in the model in depth, right? Because you can have the weights also instead of having the magnitude in the other way. Okay. So I'm just leaving it over here, and let us do the thing which we have just now come up with. Now, suppose a researcher wants to determine the underlying benefits of which consumer seeks from the purchase of the toothpaste. I have given you that file called toothpaste. I hope you all have that. And if you have installed your SPSS, please open this file, which is called toothpaste. Can you open that? Yes, I need some endorsement from your end. Yes or no? Raviji? Madam, is there any response from others? They have opened the files?
Yes, sir. Yes, sir.
Yes, sir. Yes,
Okay.
sir.
Okay. So let us just understand first the file itself. Okay. Now, in this particular, suppose the researcher wants to determine the underlying benefits of the consumer seek from the purchase of a toothpaste. So the respondents were asked to indicate their degree of agreement with the following statement using a 7-point scale, right? 1 is equal to strongly disagree and 7 is equal to strongly agree. And the results and the are over here, there are 30 respondents. Which is now, what is the variable 1? Variable 1 is the statement was it is important to buy a toothpaste that prevents cavities. Secondly, shiny teeth, right? Third is strengthening gums. Fourth is fresh breath. Fifth is prevention of tooth decay. Okay. And the sixth is most important condition is to buying a toothpaste is the attractive teeth. And seventh one, I think more one more. Okay, there are 6. These are 6. Okay, the 7th one itself is the respondent line. Okay, so these are the 6 variables on which we have taken the opinion of the people, right? Now, while we conduct the factor analysis, first of all, we have to formulate the problem, right? Then we have to construct the correlation matrix because there will be some interrelationship between these 6 variables. Method of factor analysis we have to apply and determine the number of factors which is expected. And then again, we will try to rotate the factor and interpret the factor. So calculation of the factor scores in order to interpret it and the selection of the surrogate variables have to be done. And in this way, we will try to determine the model fit. Okay. So the problem formulation itself is that we just want to understand the underlying factors, particularly in this type of situation which we have, right? So this is the correlation matrix which we get, that which actually tells you that what is the correlation of one thing with other. Yeah. Partially, you have still raised your hand, or you want to ask something over here? Will you be asking it at the end only? Please.
Sir, one of the in one of the chart that you've shared just now,
Okay.
there's one point which talks about determination of number of factors.
Yes, yes.
Could you please help me to understand this point?
Means what point you want to understand?
Determination of number of factors as
Yeah. What are the, suppose for example, these are the 7 variables are there, right? Now, when we try to understand, when we try to see the correlation among these, some things will come which will form a different type of, means when the variables will be interacting with themselves, there will be some cluster which will be formed of the variables itself. So is that cluster giving you some meaningful type of information? So that what is extraction of factors. That will be doing. Don't worry, while we'll be doing it step by step. You have your SPSS with you, Kaushali?
Yes, sir. Yes, sir.
Okay. When we will be doing it, then we'll be able to understand it in a better way. Okay.
Okay, sir. Okay.
Right.
Thank you so much, sir.
So yeah, put your hand down. Yeah. Thank you. So what we can infer out of this? Can you have some valuable insight can be gained from the examination of this matrix? What can you see? For the factor analysis to be appropriate, the variables must be correlated. Can you see the correlation? There is at least some correlation between the things. Right? In practice, this is usually the case, you can say, because there has to be some correlation. Then only it is possible to have the factor analysis, right? So if the correlation between all the variables are suppose very small, so it will be inappropriate to go with the factor analysis. And this is depicted itself with the help of the tests which we will be conducting before going with this, right? Okay. You have already opened it. So let us go with it. So can you just go with the first post slide itself? Just go on analyze. Just go on analyze. Go with this reduction, or you can say dimension reduction, and there is a factor. Can you do that? Kaushali, can you make yourself on with your voice at least all the time, so I can get the endorsement that somebody is doing it?
Yes, sir.
Oh, good. Now, step 2 is this. You can just have means all the 6 variables. Take from this to this. Okay, have you done it? Yes. All these variables, these 6 variables should be here for the analysis.
Yes, sir.
Okay. Fine. This is step 2. I hope others are also doing it. Okay. Now press this descriptives. Press this button. You will get something like this. Okay. And please make these the arrows which are there. You have to mention it, because we want to have some initial solution. We want to have some reproduced matrix, and we have to have this KMOs and Bartlett's test. Now this KMOs and Bartlett's test will tell you whether we should proceed further with the factor analysis or not. Okay, so this will give you some values which will tell you that whether we have to go with. Okay. Now press this button of extraction. Okay, you will have something like this. Okay. Now here principal component analysis is already given. Okay. And just choose with this correlation matrix, unrotated factor solution, and let this eigenvalue be 1. Done, Kaushali?
So just a moment.
Yeah, sure. Up till here, up till here, I think it is okay with everyone.
Yes, sir.
Okay. So next you can just press this options. It's a, sorry, it's rotation. Yeah, it's rotation. Okay. Now you will find this. Now, what type of rotation we will be doing is over here. It will be going with the Varimax rotation, and we need a rotated solution also. Now, mind it, previously we asked for the unrotated one, and now we are again asking for a rotated solution because now we are applying the rotation. Okay. So Varimax rotation method we are going with. There are various other methods also. Okay. So most frequently used method is this Varimax because other methods are partial rotation methods. So Varimax rotation is the means Varimax itself says that it will maximize the variable rotation. Okay. Rotated solution. Right. So next is again you have to press continue and come to this course. Okay. Come to this course. Now you have to press this display factor score coefficient matrix because that's what we need. Factor score coefficient matrix. Just press this and then press OK and then press continue and then press OK. Is this done with everyone is done with this?
Yes, sir. It's done, sir.
Okay, good. Now you might be having some solution. Okay. So have you got the solution? Just see the SPO file. SPO file is the additional file which might have come up with. You might have come up with after this. After this, press continue and press OK. Okay, you might have got some solution. Okay, the first thing is the K-Mon-Bartlett's test. I think you are getting this one. Is anyone getting something different?
Yes, sir. Getting this
Yeah.
one also, sir.
Absolutely. So Bartlett's test actually it is a test of sphericity which can be used to test the null hypothesis that the variables are uncorrelated in the population. In other words, the population correlation matrix is the identity matrix. Right. So this is the hypothesis that the population correlation matrix is the identity matrix, or you can say in other words that the variables are uncorrelated in the population. Right. And if this hypothesis cannot be rejected, then appropriateness of the factor analysis should be questioned. Okay. So it has to be, this hypothesis must be rejected. What is the hypothesis? That it is a correlation matrix. The correlation matrix is the identity matrix. It means the things are uncorrelated. I told you before also that there has to be some correlation in order to have the factor analysis. Okay. So another thing is this Kaiser-Meyer-Olkin test, which measures the sampling adequacy, whether your sample size is adequate to go for the factor. So both the hypotheses have to be properly tested. So the small values of KMO statistics indicate that the correlation between the pairs of the variables cannot be explained by the other variables, and that the factor analysis may not be appropriate. And if you need not to worry, because if the factor analysis is not appropriate, the SPSS will not run the factor analysis and will not give you any solution also. If it is giving you further solution, it means it is approved, right? So these two things are there. So people do not write about these things in the research paper or in their thesis. So these things have to be mentioned, that what is the meaning of this K-Mon-Bartlett's and how it is concluded, how you are coming up with the conclusion, right? Okay. So once it has been determined that the factor analysis is suitable for analyzing the data, so we can an appropriate method must be selected, right? So the approach used to derive the weights or the factor score coefficient, which differentiates the various methods of the factor analysis. The two basic approaches of the factor analysis are the principal component analysis and the common factor analysis. Other approaches for estimating the common factors are also available, so you can just have that also. Okay, so these include the methods of unweighted least square. You can say a generalized least square method are there. One maximum likelihood method is there. Alpha method, image factoring. These all are also given in the SPSS itself. So these methods are complex and these are not recommended for particularly for inexperienced type of users, because the most important thing is which we can go for is the PCA, that's the principal component analysis, right? So in principal component analysis, the total variance in the data is considered. The diagonal of the correlation matrix consists of the unities, and the full variance is brought into the factor matrix. So principal component analysis is recommended when the primary concern is to determine minimum number of factors. Mostly we are doing factor analysis for determining the minimum number of factors that will account for the maximum variance. Means minimum number of factors accounting maximum variance in the data, and which will subsequently be used in the further multivariate analysis. Then only we use this principal component analysis, and this is the ultimate purpose for using the factor analysis. Now the common factor analysis is also there. The factors are estimated based only on the common variance. Okay, so commonalities are inserted in the diagonal for the of the correlation matrix in this case. So this method is appropriate when the primary concern is to identify the underlying dimensions and the common variance is of the interest. And it is also called principal axis factoring. So these are the two main things and the purpose for which these two are depicted over here. Even out of these two, we mostly use the PCA. That's the principal component analysis method itself, right? In general, also, if we try to understand, factor analysis by default is also sometimes called PCA analysis, right? So when we are determining the number of factors, so what is a priori determination? Sometimes because of the prior knowledge, the researcher knows how many factors to expect and thus specify the number of factors to be expected beforehand. So you can also put this forehand. SPSS provides you the option that if you want to extract certain number of factors, it will extract only that number of factors. But that is not a good approach rather. Okay. Further, the determination of eigenvalues is also there. In this approach, only the factors with eigenvalues greater than 1 are retained. So eigenvalues, what is eigenvalue? It represents the amount of variance associated with the factors. Hence, only the factors with the variance greater than 1 are. Okay. Further, factors with the variance less than 1, they actually converge in the another factor itself to just increase the variance at some other factor level. Okay, so if we want to determine number of factors or how many factors will be determined, it will be on the basis of the tree plot which is there. So it is again on the basis of the eigenvalues which is created, and you can also do it on based on the percentage of the variance method also. Okay, so it is recommended particularly that the factors accepted should account at least 60% of variance. Means out of the total population, the 60%, complete 60% of variation should be reported. Otherwise, it will be useless to proceed further. You can go for the split half reliability, particularly, and determination on the basis of the significant stress. Also, number of factors can be brought. Okay, now you have already got the solution with you. Okay, so just see this commonalities table. So we see the eigenvalues which is greater than 1. That is a default option. Result into now here only 2 factors are there. Can you see over here? This is only there are some figures written over here in front of only 2. So we can say that only 2 factors are determined. If we see the tree plot, the factors which are above 1 are 2 only. Okay, so that's again depicts that 2 factors are there. Okay. Now,
Sir, what
particularly
is
if
the
we,
Excuse
just hold on, let me just conclude this. We will
Okay.
be able to get your answer. Okay. So, we have our a priori knowledge tells us that toothpaste is bought for two major reasons. What are these? And the street plot also associated with this has also given, right? So the two reasons for which we get, and we are getting it over here also, because this is something for which we have done the analysis. So if we finally see the cumulative percentage of the variance which is accounted for, we see that the first two factors account for 82.49%. Can you see that? 82.49% of, it is approximately 82.49% of the variance, and the gain achieved is going to 3 factor is margin, you can say. Therefore, the split half reliability also indicates that the 2 factors are appropriate. If we try to do that too, that also will indicate. Now, just see the second column of the commonalities. The commonalities are there, right, in the table. Sorry. So, what does the commonalities represent? They give relevant information after the desired number of factors have been extracted. The commonalities for the variable under the extraction are different than the initial, because of all the variance associated with the variable are not explained unless all the factors are retained. So the extraction number of squared loadings. Now see, there is again one more. Extraction sum of squared loadings. This gives the variance associated with the factors that are retained. And please note that these are same as that under the eigenvalues. Right? Initial eigenvalues. This is always the case in the principal component analysis. The percentage of variance which is accounted for by a factor is determined by dividing the associated eigenvalues with the total number of factors and multiplying it by 100. This is something which we get. Therefore, the first factor, if we see, it accounts for how much? This is 2.731 divided by number of factors, that is 6, right? 2.731, yes. This is the total one. Divided by number of factors, that is 6, and multiply by 100. How much you will get? You will get the this 45.52% of the variance. Now this is explaining 45.52% of the variance of the 6 variables. Likewise, the second factor, if we go for, then it will give you how much initial eigenvalue it is having, 2.218. If we divide it by 6, because 6 factors are being extracted, and multiply it by 100, we will get 36.969%. And combinedly, if we see both of these, this will give you 82.488. That is the, you can say, the cumulative variance explained by the factors as such. Okay. So you can even, when we rotate the factor, the interpretation, even sometimes it becomes enhanced. Now, what is rotation? No, rotation, you can say, in rotating the factor, we would like each factor to have non-zero or significant loadings or coefficients for only some of the variables, right? Likewise, we would like each variable to have a non-zero or a significant loading with only few factors, if possible with 1. So if several factors have high loading with the same variable, it is difficult to interpret them. That's why we do the rotation. So rotation does not affect the commonalities, and the percentage of the total variance explained, it will not affect, right? So however, the percentage of the variance accounted for each factor does not change. This is seen in this. Just have a look of this. Just about. You have the rotated matrix table. Just have a look of that. Just have a look of that. So you can compare the extraction sum of squared loadings with the rotated sum of squared loadings, right? So the variance explained by the individual factor is redistributed by the rotation. Hence, the different methods of rotation may result in identification of different type of factors. So where there are various methods of rotation. So we have chosen the Varimax rotation method, and accordingly we have got the results. Okay. Yes, I have already explained you. And it is also called as an orthogonal rotation because it uses the axis to rotate it, right? So there are Varimax rotation also, which I have. There is oblique rotation also when the angles are a little bit different. So when we go before rotation, it will give you some complex type of, because which variable is sitting in which type of variable, it will not tell you. But after rotation, it will be clear that which type of variable is under which type of rotation, right? Now, if we see the component matrix and the rotated matrix, you can clearly make out the difference. Now, how will you interpret the factors? Now, a factor that can be interpreted in terms of variables load high on it means more variables on the factors, more will be the loading. So another useful aid, particularly in interpretation of the plot of the variables using the factor loadings, are the coordinates. We can use the coordinates also. Okay, so if we calculate the factor scores, following interpretation, factor scores can be calculated if it is necessary or if it is as per the you can say the objective. So factor analysis is has its own standalone value. You can say. So, however, if the goal of the factor analysis is to reduce the original set of variables to a smaller set of composite variables normally which is there, or to use this in subsequent multivariate analysis, it is useful to compute the factor scores in each in case of each respondent. So the factor is simply a linear combination of original values. The factor scores for IF factor may be estimated like this, right? So the weights or the factor score coefficient used to combine the standardized variables are obtained from the factor score coefficient matrix. Okay, so means in other computer programs also they also allows you to request for the factor scores. Okay, so in case of PCA, it is possible to compute the exact factor score, and that is again why we use PCA. Moreover, in the principal component analysis or PCA, these scores are uncorrelated. So in common factor analysis, the estimates of these scores are obtained, and there is no guarantee that the factors will be uncorrelated with each other. The factor scores can be used instead of original variables in the subsequent multivariate. Now you can further utilize it for the further analysis. Okay. Now this is about selecting surrogate variables. I think it will be heavier for today's. Now this is a model fit again, which you can go with. Right. So here we have extracted two variables. Right. Now this is another important slide. You can have the gist of the factor analysis through this. That what is the complete process and flow diagram of doing a factor analysis. Okay. So we have come out with the two factors in that case. Now one is your hygiene and another one is your health. So health and hygiene, these are the two things. If you see the factors which have come up with the results, so each variable which are lying in these two, you can come out with the depiction that yes, these are the two things which are being identified with the help of factor analysis. Right? So this was all from my side. Actually, there was many things to be discussed, but yes, there is a limitation of time. So I will stop over here and thank you all for patiently listening me, and thanks to the Inspira Research Association for giving me an opportunity to interact with all of you. Yeah, any questions? If we can take Raviji, there were some participants those who have raised some hands.
So first of all, thank you so much, sir. As always, a wonderful session from your side, sir. And you take 8:30, half an hour extra for all the
I'm
participants.
sorry. I'm really sorry for that because
No,
participants,
sir. All, sir, you can see
83 still there.
participants. Yeah, 83 participants still joined. That means all are enjoying your session, sir.
I'm thankful to everyone for giving their precious time to me. Let me tell you, let me confess one thing, Raviji. Just a confession. I'm sorry I was not able to give my 100% because that's what I feel from inside because of the constraint of time. You remember me, I asked for 2 sessions while we were initiating the workshop. I asked for 2 sessions from you.
Sir, but I don't think, sir, everyone is, you can see in the chat box,
that is okay,
everyone
but,
is pleasing, sir. Everyone is happy.
okay.
So any
Anyways,
questions from your side, participants, you can still ask to Professor Pahwa, sir. I know the dedication of Pahwa, sir. In our every event, sir's contribution is always with Inspira.
No, that will always be there, Raviji.
I think, sir, you have cleared everything. There is no question from participants.
No question from just now. I think Kaushali was asking something. Is she satisfied with
He is satisfied, sir.
query?
She is satisfied, I think. Pratichi Tiwari, yes, please ask. Please unmute.
Sir, thank you for such a comprehensive session. And I agree with you, the time was not enough.
Open your video, ma'am.
Just a minute.
Professor Pahwa, sir, I think.
Yeah, for sure. Because see, though we are sitting over here at homes, but at least we can see each other and interact.
Yes.
Yeah.
Yeah, true. First of all, I wanted to know if you can share your number with me because my DRC is not yet over, so my problem statement is still not finalized. But after it's finalized, I would definitely like to talk to you again on this.
Sure.
So will it
always there?
I would be...
Yeah. So I'm just writing my number.
Okay, sir. Thank you.
It is 9634 330 885. You can write it down. And even Raviji can always share my number. 9634.
It's in the chat box.
Yes.
It's in the
okay.
Yeah.
I'll note it down. So now my question is to do this factor analysis and multivariate analysis. Is there any thing like sample size limitation that minimum sample size or something?
This is something. That's why I was telling you I was not able to give my 100%. The sample size is there, and there are some citations also for that.
Okay.
The general rule says that, and this is the appropriate one also. That number of variables which you are asking questions. Suppose, for example, we had on 6 variables over here for the toothpaste, right?
Okay. Yeah.
So multiply it by 10. So you must have at least 60 respondents.
Okay.
Okay. So the general rule, the thumb rule is that number of variables multiply by 10. That's it. That should be the sample size. That's the minimum one.
Okay.
Thank you.
Okay, sir.
Yeah, most right.
So, I think, sir, everything is done from your side.
Yeah, my side is
we
okay,
are already so late. 8:30 p.m.
Any other question or somebody wants to ask? Yeah, Kaushali's hand
Actually,
is
I want
always
to say
raised.
something before I invite Dr. Aarti for vote of thanks.
Kaushali is raising her hand, sir.
Yes, sir. I will unmute later.
Okay.
So I want to announce one thing that I will share tomorrow an assignment rather than feedback. It is very mandatory to submit the assignment. So I request all of you to please join tomorrow's session. So at the end, I will share the assignment, which will be open for half an hour only. There will be 20 MCQs. So you have to clear at least 50% score. I know you will clear with 100%, but at least 50% score is necessary for the certificate. So please join tomorrow. Okay, Kaushali ji, please, you can ask, but for one only for 30 seconds.
And without video, I will not answer.
Yeah, just a moment.
Raviji, please tell everyone to open their video.
Yes, I request everyone, because I always requested you to please open the video at the end of the session so that I can take some screenshots. I shared on the WhatsApp group also. So you will also see, you will be happy to see yourself in the session. Yeah, that's good. Yes, Kaushali ji, please ask.
Yes, sir. As the concept of factor analysis talks about the interrelationship between the large number of variables that is taken for the study. So, for instance, if the independent variables taken for the study are 3 and the dependent variables taken for the study are also 3.
Hold on,
So
Kaushali. Kaushali, just hold on. While we are doing factor analysis, we do not distinguish between the dependent and the independent variables. Okay. So the initial thing itself, the foundation should be very, very correct. I told you this in the very beginning of my session. Right? So there are variables. You forget about their interdependence and try to find out that are there some underlying factors in it. Variables are different from factors, or you can say, let me explain it this way. The combination of variables forms a factor. Okay. Suppose I have 1, 2, 3, 4, 5 variables. Okay. The combination of this will make factor. So this is one factor. This is another factor. So here, what we have just now studied about was 6 variables. 6 variables have converged into 2 factors, having 3 variables each. If you try to analyze those, you will be able to understand and know that the convergence of these 3 things have come up with number 1, health, and second is hygiene, for which we take the toothpaste. Okay, so it is concluded in that.
Thank you. Thank you, sir.
Yeah.
So thank you so much, participants. So I invite Dr. Aarti Chopra, Joint Secretary, Inspire Research Association, for the formal vote of thanks. Dr. Aarti.
Thank you so much, sir. So, sir, for Professor Manvinder Singh Pahwa, क्या ही कहें, मतलब ज्ञान का सागर जो हम हमेशा से सुनते आए हैं, वो द फ्रेज ज्ञान का सागर,
रिसर्च का सागर.
नहीं सर, you are very modest that you are saying this, that you are not able to give your 100% because of the time constraint. But what I will say, that within such a short period of time, if you are able to compress so many things and express in such a beautiful and presentable way, I'm sure you have not given your 100%, but you have given your 120%. So more than what actually participants had expected from this session, you have given much more than that. So on behalf of the organizers of this International Faculty Development Program on Research Methodology, Tools and Techniques, both the organizers, Nirvan University, Jaipur, and Inspira Research Association, I would like to express my heartfelt gratitude to Professor Manvinder Singh Pahwa for enlightening session on multivariate analysis, its classification, and so many related aspects. Sir, your expertise and clear explanation have helped and enhanced the confidence of so many participants to understand this complex topic, because these topics are so complex that the participants, especially when they are the new researchers, they are new into research, they are research scholars, they get so terrified and scared of these topics. But the way you have presented it, and most importantly, sir, the hands-on session on SPSS was an invaluable thing, allowing the participants to directly apply the concepts you have taught them in practical settings, the techniques in practical settings. And sir, I'm sure your guidance has equipped them and boosted their confidence to use them. Thank you so much once again for your time, your dedication. And Professor Modi is absolutely correct that you are always there. You are just a call away for Inspira. In every event of Inspira, you are just a call away. You are always there. And I am so thankful. We really appreciate your efforts, and we are looking forward for many more sessions, because sir, you can see the chat box. Chat box is full of appreciation and gratitude, and also the demands for many more sessions from your side. So I am thankful to you once again, sir.
Yeah,
And
thank you. Artiji, just want to have one information for everyone. Yesterday itself, we got one confirmation from ICSSR that Dr. Hari Singh Vishwavidyalaya, our Department of Commerce, is organizing one FDP of 11 days or 12 days. And it will be fully sponsored, even those for the selected candidates, even the not only the accommodation, food, but the travel may also be reimbursed. Okay, so try to find it out, and those who really want to do with this FDP, but this is on a physical basis, means a physical contact basis. So I welcome you all to Sagar for joining this, and this is going to start from 1st of August to 12th of August. It will be. So soon we will be coming up with the brochure. So definitely.
what would be the theme, sir? The theme will be
research methodology. Research methodology full complete. Even I'm taking 3-4 sessions in that. So that is one thing, and it's though it's a premature information, but for the benefit of all the participants over here, I thought I should give this different, because we have already got the approval, and it will be conducted from 1st of August to 11th of August tentatively. Means we can I can just after getting the brochure, I will definitely forward it, because this will be one of the gift from the Inspira Research Association to all of you, all the participants, those who are eager, those who are researchers, that yes, because of this platform you will be getting this information, and please be thankful to Inspira for this. And yes, because if you are from if you are a member of Inspira, definitely I will personally see that the invitation goes to you.
Thank
so
you,
it
sir.
is something which is important. I thought I should share with all of you. So
Thank you, sir. Thank you. Thank you, Professor Pahwa, sir, once again, on behalf of the organizers.
And people, those who have not taken the membership, please take the membership. It is just because it will help you for whole of your life. It is not only for doing research or just after PhD. You'll be able to understand what actually it means, right? And Raviji has already offered it at some half the price, something like that.
Yes, sir.
So please do it. This is something which is being motivated and inspired by our.
Sir, we are also organizing an international conference in hybrid mode, offline mode.
Okay.
The month of July, 26th and 27th July.
Okay, that's great.
Definitely,
so
we will invite you here at Jaipur. This is your hometown, sir.
Definitely.
So get ready, sir.
Sure.
So we will share the brochure very soon with all of you. 2 days international conference here at Jaipur. So we are also inviting you.
And let me tell you one thing, I started with it, that I have also learned many things from this platform. So this is a very precious platform and very pious platform you have. No? So this is something at very least cost, just a cost of organizing the thing. You get so much of knowledge. So hats off to Inspira, and hats off to, first of all, our honorable respected SS Modi sir, who has incubated this idea of having such type of interaction and such type of means a platform. And thank you, sir, always, and I seek your blessings always, sir.
Thank you so much, sir, once again. And tomorrow, so tomorrow is the valedictory day, last day of this FDP, on the topic how to publish an article in top tier journals by Dr. Jitesh Kumar from Taylor's University, Malaysia. So we will meet tomorrow at the same time. And tomorrow, I once again telling you to please join tomorrow, because tomorrow we will share an assignment which is really a mandatory thing for the certificate. So thank you so much, Professor Pahwa, sir. Thank you so much, Dr. Aarti. Thank you so much, all the participants. So enjoy the India-England match also. It is going to start very soon. And